My name is Dominik Kress, as you already have heard. I'm the author of this funny book, and I have one copy in here, so if you can read German and you're interested in it, just explain to me why you should get it, today somewhere, and the best explanation, I'll just hand a free copy of it. So talk to me about APIs, cloud and DevOps. Actually, as a product owner, I really talk a lot about cloud nowadays. People and Liverpool FC, if you also are into football. But let's get started. Back to basics. I have seen that you are a very experienced crowd today, so we can rush a bit through that. But what's GraphQL? Well, basically GraphQL as a specification of a platform-independent query language for APIs has a lot of cool things like schemas that define relations between entities and their dependencies in graphs. Just to reiterate, I hope this is nothing surprising for you today. You have queries, you have mutations to fetch data and to manipulate data. And then you have parameters and variables and all the fun things to really enrich your schemas and your queries. If you're interested in more basics, you can read the two great books that are on show today. That's basically how a query looks. We can skip that. But here's the important part. Resolvers are a very important thing of GraphQL because resolvers resolve queries into queries and mutations into the business logic, and with that into the services. So you get a query, then the resolver looks it up, and with that sends back the data from a specific service somewhere. All right, this is how it looks basically. So the very important part right now for this talk is the resolver at the end that resolves a schema, well, a query basically from a schema into a specific service. And what are API gateways? Well, an API gateway moderates between a client and multiple backend services. It's basically something like an API combining reverse proxy that gets some calls from the clients and then just distributes it to different backend services, basically to the right backend service where it has to land. And why would you do that? Well, you have a single touch point for your consumers, you have an abstraction layer for multi-team dependencies and so on. You have you can map your different services within a microservice, the different APIs that might come from different teams onto a singular pattern, making it easier to access it for other consumers and so on. So that's basically how such an API gateway can look. You have a client calling on one single touch point that resolves to, well, it's German, but well, it resolves to different services like in a shop, a product service, a card service, or a billing service. And looking at a comparison between the two now, on the one side, we have API gateways that receive requests from a client and then delegates those requests to various backend services. While on the other side, we have GraphQL who receives requests from a client and then delegates it via the resolvers to various services in a backend. So you can already see there's a thing going on between the two. It's not that far-fetched to compare them to each other. And now the question is, sure, how can we combine those two? Making it easy, the cool thing on GraphQL is, as we already have heard in the short introduction of it, it is platform independent, so it doesn't really care, or the resolvers don't really care where it resolves the data into. And it doesn't care about the type of the service or whatever. And the funny thing about it, or the more interesting thing is, well, it doesn't even have to be a service within its application. You can also create resolvers resolving into other remote origins or remote services. And that really enables us to combine GraphQL as an API gateway with other, GraphQL schemas or with other even REST APIs. So how do you create a remote schema to make your resolvers or enable your resolvers? to call other services, not just the service within your own application having the GraphQL API. Well, there's a big tool that really helps you with it, which is GraphQL Tools, which really has a lot of tools to enable you, or a lot of functions to enable you to use schema stitching or schema merging in order to get your merges or your schemas merged together, to have one central place, one individual touch point. And on the other side, we also use in the coming example Apollo as a wrapper around GraphQL, so that I don't need to create so much overhead for this example. So what do we do with GraphQL tools in order to make it possible? Well, there are basically 4 things that help you with that, or 4 steps. First, you have to create an executor that can then execute your schema. You have to introspect your schema, so basically find out how your schema looks and combine it for the executors in order to make it executable. So then you have an introspected executable schema that you could use for calls. With a wrap schema, you get it together as a combined schema, and with merge you can merge it with other schemas that are wrapped with those functions before. So executed and wrapped schemas can be merged together. So basically it looks like that then in short. You have various schemas of other remote GraphQL APIs that you can wrap with the wrap method and make executable and introspect with the other methods. And you could even create some type definitions and resolvers for basic REST calls. And then you can merge those type definitions and resolvers and those executable schemas together. And then you have one schema at the end. That is your API gateway schema. So, so much for some theory in general. Let's see some code if that really works out well. First thing, I use 2 example applications for this. One is a JavaScript-based catalog service. It looks a bit like that. So you basically have customers and products, and customers have wish lists, and wish lists have products, which is then the graph of this data for this example. On the other side, you have a Java-based order service, which looks a bit like that. So you have customers, and customers have addresses, and they have orders, and orders also have delivery addresses with them. So that's then the graph on the other side. And those 2 services are currently running. We won't get too deep into them because they don't really, it's just 2 remote GraphQL APIs that we want to now combine to create an API gateway for example, our marketing, making a comparison between the wish lists of a specific customer and the orders at the end of that same customer. So looking at that, we really need to also have some design thoughts on that, because you can't just combine them and then be happy with it, because one problem can be the IDs. So with 2 different systems and then customers in those 2 different systems that are bound just to that service, you might have problems if they have different IDs. So you need global unique IDs in order to fetch it, or to fetch the same entity over all the services that are behind your API gateway. So in this case, you can implement an ID service to get the ID over every services, or whatever way there is. For our example, I just faked the IDs of the test data in a way that they all have the same ID. On the other way, you need global unique names, because if you merge the schema, it just can have one resolver against, or one entity can have one resolver against one of the remote schemas. So in our case, we have customer in the one service and customer in the other service. We can just resolve against one of those remote schemas with customer. We cannot resolve against both, and then merge the end together. So you really have to make sure that those different entities and different services really have different names, if you want to call them, or else they will override each other. There you can have a global vocabulary or something shared over your multiple teams to make sure that nobody really duplicates their names, or you can have prefixes, fixed prefixes, or you could also map your names on the layer of the API gateway with a function that is called transform. We will see that in our example because we have the problem with the customer account. But now, so much theory. Now really some code, and also some spoiler alert. I created that code a couple of weeks ago, and I did an initial run, and in the meantime GraphQL Tools did a breaking change. So when I just tried to update it today, it had some problems because they changed the package structure within GraphQL Tools, and I think they also changed some other things. But I looked through the documentation, and the basic idea behind it is still the same. So it should all look familiar, but I think the package structure will not work like in that example with the newest version. So keep that in mind, just don't copy it completely. Or you need the older version. Because I tried to update it today and then nothing worked, and I was like, oh yeah, all right, I'll not update. All right, so what we need, and here is the first hint about it. Please don't just copy it exactly like that. Check the documentation because the package structure changed. But here's what we actually need. So I already talked about, we need an introspect schema, we need a wrap schema. We need merge to merge everything, and then we can delegate with the delegate to schema function, and our rename types and rename root fields will be really important functions for our transform at the end. So, and Apollo server, to set up the GraphQL server at the end. So first off, we need to create our executor, as I already said. In this, we can just return this executor function, basically where we fetch a specific URL where we will just push in our remote URL so that we can stringify all of our queries in there. And then get a JSON back from from our GraphQL introspection at the end. So with that, we can create a remote schema. As you see, we create an executor with a specific URL, and then wrap it into our wrap schema so that we get a wrapped introspected schema from our executor. So with that, we also know that we have to manipulate something. So going into that, we know we need customer, or we manipulate the customer field in both. We rename the types that are customer types and suffixes it with our service name. And we rename our root field with it, which is just a query field that we also just prefix with our service name. So this is a very easy transformation of your executable schema at the end that you then can just use like that. And so after that, we create a new the actual new schemas, which is in our case the catalog schema. Just give over the URL. And the order schema, which is also just giving over the URL. And then we merge those two together. And then, that's already everything that we need in order to have, a merge schema or a schema working together. But also here, we transform some of those fields. So if we now get a query with, an order customer, the actual query in the order schema doesn't, or the actual order schema doesn't know how to resolve it, or your API gateway doesn't know how to resolve it, since it doesn't have an order customer within one of those schemas. So we first create a new schema for our API gateway, defining the customer type with the order customer for order and the catalog customer for catalog. Then we create the resolvers for it. Here you can see that we link to the catalog schema and here to the order schema and delegate to that specific whenever we get the field order customer or the field catalog customer. So with that, we resolve to the right executable remote schema. And then we merge it again together, but this time also defining the type definitions or adding the type definitions to it and adding the custom resolvers we have. In this step, you could also just use whatever field and then resolve onto a remote REST API or something, so that you can add other services in here as well, and then just give back the response of a remote REST API. All right, and that's all the magic. So in this case, we could just directly see the thing. So looking into our code, here's our index file. You will directly see that it's nothing different. We create an executor, we create the remote schema, then we call it with the two schemas, define the link graph, custom resolvers, and merge the schemas. And then we run the server just basically with our Apollo server. Looking at our, this is the GraphQL, so it's the order service with Java. We can just run it, and then we see, all right, we have our customer Luke Skywalker in here. We see our playground, which is basically also just, just to show you that it's running in the background, with also Luke Skywalker and his special, wish list. And then here is our service, which you can also just directly see in here. We are in GraphQL API Gateway, and it's running. And then here is our special query with the ID 4, which will be Luke Skywalker. So running it, you can already see the result. We have our customer with the ID, then everything of its order, and then everything of his wish list thing. So that's basically both combined. And you could extend it even further, make it more complex at the end, get even more GraphQL APIs into it. And yeah, GraphQL Tools is really a very nice utils class or set to help you there. So going back to our show, that is then already everything that I can show you about it. And I hope I was in time. All right, any questions? I think for that we have this special thingy here. Yeah, sorry to. I'll hope it just, yeah, perfect.
Well, not really a question, but
yeah.
So one of the slides showed the repo.
Mm-hmm.
One of the slides showed a repo that was public, so I wanted to know if it's...
Oh yeah, sure. You can find the whole code of the. Keep in mind, it's not the updated one in this repository of me. You can also find the other applications within GraphQL Basics, and within here, the Java example in GraphShop Final. All you have to do, again, if you want to use those two applications, is to tweak in JavaScript example, tweak the ID of the model base data. It's just in here. Then you have the customer data and change that to a 4, and then you're good to test it out. Yeah, but again, keep in mind, don't upgrade or update your npm dependencies within the other one, within the repo. I really have to invest some time to find out what exactly they changed in the GraphQL tools. But until now, I really think it's just a package structure. They have all of the rep functionalities in rep, all of the delegate functionalities in a subfolder delegate, and I think that's the biggest thing that changed. All right.
Yes. Is the schema baked in at compile time, or does it fetch the schema on every request from the subservices?
Well, it's on compile time, so
Okay.
it doesn't fetch it every time. So whenever you back schema changes, you should also just restage your app.
Ah, okay, thanks.
So I'm quite new to GraphQL. So when you make, for instance, the routes in REST API, so what do you change here? Like, how do you do? I didn't get it quite. So you, because schema is in the beginning, right? When you define the data structure, like
you can bind REST API calls just as individual calls within your resolvers. So a resolver can just remotely call another REST endpoint and then get that data of that REST endpoint. You won't have any control over, the inner structure of whatever that REST endpoint gives you back. So it just prints out that JSON as it is. But, it's a REST endpoint, so you can't expect to transform it into GraphQL where you go deeper into, because that's also not what REST is planned for. So the structure should be flat anyways. Does that answer the question?
Yeah, maybe I'll ask you later.
Okay. So basically, you could bring in an Axios to just do a GET request within your resolver, and then return whatever that Axios GET request is returning to you, which should be a flat JSON hierarchy, and then just print out in your GraphQL response that JSON as part of this, field, whatever you called. But we can talk about it later as well. All right, right in the back, there was also a question.
What happens to authentication, authorization? Does it just pass through each headers? What happens if one resource is not authorized?
All right, so the question was, what happens to authentication and authorization within that? Well, it's basically the same as GraphQL generally. GraphQL doesn't really care about the authentication, since it's just a query language for the API. So you would have to manage the authorization besides it. I think Apollo has some good features on how to authorize and authenticate your app. Then you just would deliver your authorization in the header of the request against your remote schema or something like that. I've never really tested it out with authenticated services. Sorry. All right. Good. Then thank you.